Hi everyone, welcome back to the another video of Engineers Academy. So guys, over here in this video we'll be talking about the heat and specific heat of different substances basically. So guys, in our previous video we have seen the different kinds of the systems and different types of the energies which is there in systems. So as the systems are related to the different bodies over here. So guys, welcome back to the another video of Engineers Academy. If you are new to my channel, just do subscribe to my educational channel Engineers Academy, and guys, please hit the bell icon so in case of whenever I upload a new video you will get an instant notification. So guys, without wasting any time, let's begin with today's topic, that is of the heat and specific heat of different substances. So guys, as we all know, the heat. So heat is nothing but the type of energy which flows from hot body to cold body. It means which flows from one system to another system. To be precisely, when it is flows from one system which is at higher temperature to another system which is at lower temperature. So that's the nature of the heat. Heat flows from hot body to cold body. So guys, basically heat is like denoted by the capital letter Q, and it is expressed in kilojoules and joules. So basically this is the unit of the heat is joules or kilojoules. So it is named after the famous scientist Mr. Joules. So that's why it is like the unit of the heat will be there in joules. As this Mr. Joule, he has done some kind of experiments on the heat and work. So he says that the heat and work are mutually convertible. So this is the main reason, like this particular heat is expressed, the unit of the heat will be there in joules. Earlier it was there in calories. The unit of heat was there in calories. In ancient time they were like it is called as, they measure this particular heat in calories. So when we go to gym, we exercise, we burn calories. Like it means we exercise, it means we do some kind of work, we bring our body at higher temperature, and due to that higher temperature our just body like burns fat, and ultimately our body loses calories. So that is the different logic over here. So this particular heat can be, it was there termed in calories in the ancient times, but right now it is termed in joules and kilojoules. So guys, this particular heat transfers from hot body to cold body. So now let's talk about the transfer of the heat. So this particular heat, when it is flows through the solids, it is called as the conduction. When it is flows through liquids, it is called convection. And when this particular heat flows from gases, it is known as the radiation basically. Suppose I am having a bonfire and I am just standing next to the bonfire. The heat from the bonfire is a particular system, and I am standing next to the bonfire. It means I am also at a different system, different surrounding. So basically this heat from the bonfire will flows towards me. The bonfire is at higher temperature and I am standing next to bonfire which is I am having at the lower temperature. So that's why this particular heat flows from the bonfire to me, and I can feel the heat, I can feel the temperature of the bonfire. So this is nothing but the radiation which occurred over here. It means the flow of the heat from bonfire to the person which stands nearer to the bonfire, this is called as the radiation. Suppose I want to boil water over here. So I just bring my utensil which is filled with water to the heat source. I started heating that particular water. Water starts vibrating. The internal molecules of the water, they starts vibrating. It means over here the water molecules, the heat transfers from these water molecules, and that particular transfer is known as the convection which is occurred over here. In case of solids, the heat directly flows. The heat is having, there will be the sufficient surface area for the flowing of the heat. So this is known as the conduction basically. So guys, in case of gases, suppose vacuum is there. In case of gases, suppose vacuum is there, So the heat will also flow through that particular vacuum in terms of radiation basically. So guys, that is nothing but the heat and the heat transfer we have seen. Now let's talk about the specific heat. So guys, the specific heat can be termed as the amount of heat which is required to increase the temperature of unit mass of substance through 1 degree Celsius. It means it is basically an amount of heat required to increase the temperature of that particular body through 1 degree Celsius. But over here I have used the word unit mass. So it is the unit mass of the body basically. So guys, this particular specific heat is denoted by the small letter C, and it is expressed in kilojoule per kg per Kelvin. So it is expressed in kilojoule per kg. So kilojoule is the heat, kg that is the mass, and Kelvin is the temperature difference over here. So guys, this is called as your specific heat. Now this particular specific heat, I can also call it as the heat absorption capacity. In case of water, the heat absorption capacity is more than that of the steel. In the water will be having the specific heat of 4.18, whereas in case of the steel it is only having the 0.49. So this is the specific heat which is expressed in kilojoule per kg Kelvin. So this is the specific heat which is different for different substances, for different bodies. So now let's take one example over here. Suppose I am having water which is at the ambient temperature at 25 degrees Celsius, and I just heat that particular water up to 100 degrees Celsius. So can you calculate the amount of heat I have given to water to raise its temperature from 25 to 100 degrees Celsius? Can we calculate this amount of heat required over here in this example? So basically we can calculate the amount of heat which is absorbed by the water by using the formula of M into C into delta T. So delta T is nothing but temperature difference, that is the 100 minus 25 is equals to 75 over here, delta T is, and the mass of the water, let's say it is of having a 2 liters. So the specific heat of the water, so 2 into specific heat of the water 4.18 into the temperature difference, that is the delta T, that is 75. So guys, after solving the equation we get a value of 627 joules. So this 627 joules is nothing but the amount of heat required to raise the temperature of water from 25 degrees Celsius to 100 degrees Celsius. So this is the amount of heat required, that is 627 joules. So guys, this is how we can calculate the amount of heat required. So guys, in case of solids and liquids, this is having only one type of specific heat, but in case of gases, the gases will having two different types of specific heat, such that the specific heat at constant pressure and the specific heat at constant volume. So it depends upon the scenario, it depends upon the gas which is kept at constant volume or the gas which is kept at constant pressure. And if we try to increase the temperature of the gas, then in that case the heat generated or heat transferred we can calculate by using this particular Cp and Cv, the specific heat at constant pressure and the specific heat at constant volume. So guys, over here in this video we have seen the heat, we have seen the heat transfer, and also we have seen the specific heat for different substances. So guys, I hope you understood this simple topic of heat and specific heat. So guys, in case of any doubts, just leave a comment below, and guys, please do subscribe to my educational channel Engineers Academy. Also guys, please do share all my videos to your social networks, to your friends, family on the different portals as well. So guys, thank you for watching my video. Please do subscribe to my educational channel Engineers Academy.